Good afternoon to everyone. Welcome to YouTube channel DEO Nalgonda. Till now, we are discussed in part 1 and part 2 solution of one right angle triangle which is given by the given word problem or situation. Let us discuss what will be the solution of two right angle triangles formed by the given situation. Okay. For that, we are considered two example problems. The first one is that suppose you are observing the top of the palm tree. You are observing the top of the palm tree. So, let us denote palm tree, a vertical line by palm tree. Base of the palm tree is A, top of the palm tree is B. At an angle of elevation 45 degree. So, suppose you are observing from point C to the top of the palm tree, and draw a horizontal line through the observation point. The angle of elevation is 45 degrees. Okay. The angle of elevation changes to 30 degree. This angle of elevation changes to 30 degree when you move 11 meter away from the tree. From this point C, you are moving again 11 meters away from the tree. Let us denote it by 11 meters and finally you reach at point D. Okay. Then join top of the palm tree to the observation point D. The angle of elevation changes 45 to 30 degree. Okay. Then what we have to find? Find the height of the tree. Let us denote height of the palm tree by h meters, as this distance given in meters. So, height must be in terms of meters. Okay. And let the distance of A to C is x meters. Distance of A to C is x meters. Therefore, solution. What is AB? AB equal to height of palm tree. Let AB equal to h meters and AC equal to x meters. Given DC equal to 11 meters and the angle of elevations BDA equal to 30 degree, another angle of elevation BCA which is equal to 45 degrees. These are the given values. Okay. Now we have to find this height of palm tree, so that now in right angle triangle ABC, I am considering this triangle ABC. So, what is x? It is a adjacent side of 45 degree. What is h? It is opposite side of 45 degree. Then the ratio of opposite to adjacent is tan. So, consider in right angle triangle ABC tan 45 degrees. The side opposite to 45 degrees h meters by the side adjacent to 45 meters is x meters. That is tan 45 value is 1 equal to h by x into 1, x equal to h. Let it be equation 1. And we have another right angle triangle. What is that? DAB, right angle at vertex A. DAB. In right angle triangle DAB, the angle of elevation is 30. Let us take tan 30 degrees. Tan 30. So, for suppose, don't consider BC. So we are taking only DAB triangle. Opposite to 30 degrees AB, that is H meters, and adjacent to 30 degrees DA. What is the value of DA? X plus 11 meters. Adjacent to 30 degree is DA, that is x plus 11 meters. Tan 30 value is 1 by root 3, which is equal to h by x plus 11. That is, by cross multiplication, x plus 11 equal to root 3 h. But from 1, x is replaced by h. X is equal to h. Therefore, replace x by h. What we get? H plus 11 equal to root 3 h. Since from 1 x is equal to h, so we replaced x by h. Now, so transform this h. 11 equal to root 3 h minus h. 11 equal to h is common term for the first term and second term. Take it away the common term. What we have in the first term is root 3, in the second term is 1, as 1 into h equal to h. So transform multiple of coefficient of h to LHS, we get 11 by root 3 minus 1 equal to h. Therefore, this is meters. 11 by root 3 minus 1 meters is the height of the palm tree. Height of the palm tree is 11 by root 3 minus 1. We can simplify further also, but no need here. Right. Example 6. Two men on either side of a temple. Two men stands. Maybe the word is missing here. Two men stands on either side of a temple of 30-meter high. Let us consider first this is a temple. For our mathematical convenience, we denote height of the temple by a vertical line. Let us say that AB is temple and its height is 30 meters. Its height is 30 meters. Okay. But here two men stands on either side of the temple and observes its top at the angle of elevation of 30 and 60. Here the person P stands one side of AB and the person Q stands on the side of temple AB, and they are observing top of the temple, from P and Q. They are observing top of the temple. The angle of elevations are 30 degree and 60 degree. This is observer point and this is observation point, that is object. This is a line of sight. Draw a it's a horizontal line through observer P and Q. Draw a horizontal line through observer P and observer Q. The angle of elevations are respectively 30 degree and 60 degree. Find the distance between two men. So we have to find distance between P and Q. That is PQ length is we have to find here. Right. For this, let us suppose say that distance between P and A is x meters as temple height in meters. So PA, let us suppose that distance between P and x meters, distance between A and Q is m meters. So we have to find x plus y meters equal to how much? Okay. What is the given information in the question? Let us write. AB is a temple of height 30 meters and P is the observation point, and let PA equal to x meter and AQ equal to y meter. What are P and A? P is the observation point of one man and Q is the observation point of another man. Both are either side of this temple. Okay. Now the given angle of elevations BPA equal to 30 degree and angle BQA equal to 60 degree. Consider in triangle, right angle triangle BAP. Right angle is at A. Here also it is also right angle. Right. In right angle triangle BAP, we have to find adjacent side of 30 degree. We have to find adjacent side of 30 degree and given opposite side of 30 degree. So we have to consider ratio of opposite to adjacent. So that we have to take tan 30. Opposite to 30 degree is 30 meters by adjacent to 30 degree is x meters. Meters gets cancelled. What is value of tan 30? That is 1 by root 3 equal to 30 by x. By cross multiplication, x into 1 equal to x, root 3 into 30 equal 30 root 3 meters. This is the x value. Let it be 1. And in another triangle, another right angle triangle BAQ, we have an angle of elevation 60, but we have to find the adjacent side of 60, that is AQ. We have to find adjacent side of 60 degrees AQ and given opposite side of 60 is 30 meter. So the ratio of opposite to adjacent takes tan. So consider tan 60 in triangle BAQ. Opposite side of tan 60, opposite side of 60 degrees is 30 meters. Adjacent side of 60 degrees is y meters. Tan 60 is nothing but root 3 value 30 by y. So y root 3 equal to 30, y equal to 30 by root 3 meters. Thus, let it be equation 2. But we have to find the distance between two men P and Q. Therefore, distance between two men P and Q is equal to x plus y meters. Substitute the values of x and y. What is the value of x? That is 30 root 3. What is the value of y? Y is 30 by root 3. Let us simplify 30 by root 3. 30 can be written as 10 into 3 by root 3. We know that 3 by root 3 is 3. Since 3 by root 3 can be simplified as 3 can be written as root 3 into root 3 over root 3. Root 3 gets cancelled. What we get? Root 3. So students, always remember 3 by root 3 equal to root 3. That will help you to simplify the questions in a trigonometric applications of trigonometry. So 30 root 3 and this is value is 3 by root 3 is root 3 and into 10 root 3. 30 root 3 plus 10 root 3, add the coefficients of root 3, 30 plus 10, that is 40 root 3 meters. This is how the solution of two triangles when the given situation demands. Okay. So this is how we calculate the value of height of respective tree or distance between 2 points. Okay. Let us see some of the questions of exercise 12.2. Okay. Let us see some of the questions of exercise 12.2. Now, let us discuss the solutions of problems in exercise 12.2. Okay. I am taking second problem. Why? Because first problem is homework for you people. Okay. Right. 1.5 meter tall boy. Here the height of the boy is given. Here the height of the boy is given. Height of the boy is given. So we should consider its height in the figure. Okay. 1.5 meter tall boy. Suppose This is the height of the boy, that is AB. Say that AB. What is the height of tall boy? That is 1.5 meter. Okay. He is looking at the top of a temple which is 30 meter in height. So, in certain distance there is a temple. Let us denote top of the temple by, so CD is the height of the temple. The height of the temple is given that 30 meter. At the top of the temple which is 30 meter in height from a point at certain distance. Let us denote it distance by certain. We do not know distance between boy and the temple, right. The angle of elevations from his eye to the top. So, boy eyes are here, elevations from his eye to the top of the crown, right. This is the crown, this is the top of the temple crown, right. This is the line of sight, the line joining eyes of the observer to the crown of the temple. And consider a horizontal through eyes of the boy. Consider a horizontal through eyes of the boy. Let us denote this point by E, which is a perpendicular to the CD, right. The angle of elevation is crown of the temple increases from 30. First angle of elevation is 30 degree and it changes from 30 to 60 as walks towards the temple. As he walks, boy is here, he walks towards the temple, he walks towards the temple, okay, certain distance. After walking certain distance, boy is, the place of boy is, let us denote PQ. Height of the boy is 1.5 meter, so it is also 1.5 meter. From this point Q, he is observing crown of the temple, then the angle of elevation changes from 30 to 60 degrees. Yes, it is 60 degree. So, distance, find the distance he walked towards the temple. We have to find this distance. We have to find this distance. Okay. So, let us denote it by this x meters. Let us denote it by x meters. As height of the boy is given in terms of meters, so let us denote it distance by x meters. Okay. Now, actually height of the temple is 30 meters. Height of the temple is 30 meters. But see in the figure, AB equal to PQ equal to CE. So, CE or EC distance is 1.5 meters. So, remaining distance ED is 30 minus 1.5, that is 28.5 meters. 28.5 meters is ED. And let us denote the distance between Q to E by y meters. By y meters. So, solution. CD is height of the temple, which is equal given by 30 meters, which is given by 30 meters. And AB as well as PQ as well as EC are the height of the boy. Which is equal to 1.5 meters. Let BQ, the distance he walked, the boy walked distance from B to Q is x meters. We have to find this x value, and also QE equal to y meters. And the angle of elevations are DBQ equal 30 degree and angle DQE equal 60 degree. And DE, what is DE? DE is CD minus EC. Total height is 30, subtract 30 minus 1.5, we get DE length. That equals CD is 30 meters minus EC is height of the boy, which gives us 28.5 meters. Right. These are the values taken from the figure. Right. Now, let us find the distance boy walked towards the temple. For that, consider right angle triangle EDEQ. Consider right angle triangle DEQ. Tan 60 equal to opposite to 60 degree is DE, adjacent to 60 degree is QE. Substitute the value of DE. DE is nothing but 28.5 meters by QE is Y meters. QE is Y. But tan 60 value is root 3. Root 3 equal to 28.5 by Y. Since Y equal to 28.5 by root 3, but this 28.5 is a multiple of 3. So 3 9s are 27, 3 5s are 15. Put a decimal point. 9.5 into 3 by root 3. In the earlier problem we have discussed 3 by root 3 is nothing but root 3. So this is equal to 9.5 root 3 meters. This is Y. Okay. But we have to find X value. So consider another triangle. So I am drawing again triangle here. DEB. This length is x plus y, as BQ is x and QE is y. BQ plus QE is BE. So BE's value is xy, and this is 28.5 degrees. Angle of elevation is 30 degree. So consider tan 30. Consider right angle triangle BDE. I am considering tan 30. Tan 30 equal to opposite to 30 degree 28.5 by adjacent to 30 degrees x plus y. That implies tan 30 is 1 by root 3 equal to 28.5 by x plus y. But we know that value of y by cross multiplication x plus y into 1. X plus y equal to root 3 into 28.5. 28.5 into root 3. Substitute the value of y. Y equal 9.5 root 3. Therefore, x equal 28.5 root 3 minus y. Now substitute the value of y. What is the value of y? 9.5 root 3 meters. 28 minus 9. That is 19. 0.5 gets cancelled. Subtraction 19 root 3 meters. Okay, this is what 19 root 3 meters. Also we can write root 3 equal to 1.732 for further calculation, but no need to write down. That is the distance the boy, therefore the boy walked 19 root 3 meters towards the temple. This is how the solution of problem 2. Okay. Now we are dealing with question number 3. Right. A statue stands on the top of a 2-meter tall pedestal. Every statue stands on pedestal. Sum of the height is pedestal, and above the pedestal we put a statue. So let us say that this is pedestal. This is what? Pedestal. Height of the pedestal is AB. This is pedestal. A statue stands on the top of the 2-meter height. The pedestal is 2-meter height as given in the question. Statue stands on the top of a 2-meter tall pedestal. Yes, first of all we have to consider 2-meter height pedestal. And on the pedestal a statue is standing. So BC is the position of statue on the pedestal. From a point on the ground, so for suppose from this point, let us say this point is D. From the point D on the ground, DA is the ground. DA is what? Ground. On the ground, the angle of elevation of the top of the statue is 60. Angle of elevation of top of the statue is C. This angle of elevation is what? 60 degree. What is this? 60 degree. In triangle ACD, angle CDA is 60 degree. This is the angle of elevation. And from the same point D, and from the same point, that is D, the angle of elevation of top of the pedestal. This is the top of the pedestal. Angle of elevation of top of the pedestal is 30 degree. Not 30 degree, sorry, it is 45 degree. And the same from the same point, the angle of elevation of the top of the pedestal is point B. The angle of elevation is 45 degree. Find the height of the statue. We have to find height of the statue. Let us say h meters is the height of the statue. As height of the pedestal is given in meters, so let us say that BC is the statue equal h meters. Solution. And the distance between point of observation on the ground to the foot of the pedestal is x meters. Let us write what is the statue, what points denotes pedestal. AB is height of the pedestal. Height of the pedestal, which is given by 2 meter in height, and BC is height of the statue. Let its height by h meters. Not it is given, right? And let AD equal to x meters. And what are the angle of elevations? In triangle ACD, angle of elevation CDA equal 60 degree, and in triangle ABD, angle of elevation BDA equal 45 degrees. That's very important. Okay. Now the total height from C to A is h plus 2 meters. Up to B h meters, up to A, B to A is 2 meters. Total is h plus 2 meters. Yes. AC equal to h plus 2 meters. These are the information we collect from the figure as well as from the question. Now let us solve this. Consider the smaller triangle ABD. This is the triangle. I am considering only ABD. Let us write here again, draw the ABD triangle again. DAB. This is 2 meters, this is x meters, and this is 45 degrees. Tan 45 equal to, why always I am taking tan 45? You have to find the adjacent side of 45 and given opposite side of 45. The ratio of opposite to adjacent is tan ratio. So that 2 meter by 2 by x. 45 equal to 1, 1 equal to 2 by x. Thus x into 1, x equal to 2 meters. Let it be 1. Now in triangle ACD, again I am drawing ACD. This is x, CAD. This is 60 degree angle, h plus 2 meters total height. Tan 60. Tan 60 equal opposite side to 60, thus h plus 2 by x. Tan 60 is root 3. Root 3 equal h plus 2 by x. But what is the value of x from equation 1? X equal 2 meter. Replace it. H plus 2 by 2. 2 into root 3. 2 root 3 equal h plus 2. Thus h equal 2 root 3. Take plus 2 from RHS to LHS. It would become minus 2. H equal 2 of root 3 minus 1 meters. This is the height of the statue. Height of the statue is 2 of root 3 minus 1 meters. Okay. Therefore, height of the statue is equal to 2 of root 3 minus 1 meters. We can simplify further also by putting root 3 equal to 1.732 minus 1 into 2. Okay. This is how we are find the solution of two right angle triangles formed by given situation. Here DEB is one right angle triangle, DEQ is another right angle triangle. Here also ABD, ACD are two right angle triangles. Okay. Now let us see some more 2 or 3 problems to discuss the solution of those problems. Now we are discussing question number 4 and 7. So question number 4, first of all, from the top of a building, let us consider AB is the height of the building, A is foot of the building, B is top of the building. The angle of elevation of the top of a cell tower, always cell tower is more height than building. So consider CD as cell tower. Consider CD as cell tower. The angle of elevation of top of a cell tower is 60 from the top of the building. From the top of the building, angle of elevation of top of a cell tower is 60. So this is the top of the building to the top of the tower. Angle of elevation, to write angle of elevation, first of all consider a horizontal line through B. So angle of elevation is 60 degree. From the top of the building, the angle of elevation of top of the tower is 60 degree. Okay. And the angle of depression to its foot from the same point B, from the top of the building to the foot of the tower, angle of depression is 45 degrees. Okay. If the distances of the building from the tower is 7 meter, distances between building and the cell tower is 7 meters. Okay. So what we have to find? Then find the height of the tower. Let us denote height of the tower B. This is point E. So total height is h meters. Let us denote it by total height of the tower is capital H. Let us say, but this 45-degree angle is always equal to this angle, as these two lines are parallel and BC is transversal, then these two angles are alternate interior angles and hence they are equal. Okay. Let this is x, then BA is equal to EC, as AB EC formed a rectangle, opposite sides are equal, x, and let us suppose it is by y. Let us write what constructions are made here in the figure. Okay. CD is the height of tower, height of cell tower, thus CD equal to CE plus ED, which is equal to x plus y. Okay. Then and AC is 7 meters, but AC is equal to BE, as ABEC is a rectangle. Since it is right angle triangle, it is also right angle triangle, it is also right angle triangle, it is also right angle, not a triangle, all corners are right angles. Okay. So that AC equal to BE, AC equal to BE. Since ABEC is a right angle, its opposite sides are equal, therefore this distance also 7 meters, BE also 7 meters. And the angle of elevations DBE is 60 degree and the angle of depression EBC is 45 degree, but this depression angle is equal to this elevation angle BCA. Okay. These are the information given in the question and as well as from the figure. Okay. Now, to find the height of the CD, let us consider two triangles. One is BED, another one is BAC. From right angle triangle, from right triangle BED, this is angle of elevation is 60 degree, consider tan 60 degree, tan 60 equal opposite to 60 degree y by adjacent to 60 degrees B, that is 7 meters. Tan 60 is root 3 equal to y by 7, thus y equal 7 root 3 meters. Let it be equation 1. From right triangle ABC tan 45 equal opposite to 45 is x, adjacent to 45 is 7, tan 45 is 1 equal x by 7, 7 ones are 7 equal x, equation 2. Thus if it is 7 meters, then it is also 7 meters and y equal what? 7 root 3 meters. Thus height of the cell tower is h equal or not h, x plus y. Height of the cell tower is x plus y, that is height of the cell tower is CD, x plus y, x is 7 meters plus y is 7 root 3 meters, thus equal, take away the common term, 7 of 1 plus root 3 meters. This is the height of the cell tower CD. So, 7th question, let us see 7th question. Two poles of equal heights, yes, here given that two poles and they are equal in heights, Consider two poles. So, AB is first pole and CD is second pole. Okay. They are standing opposite to each other on either side of the road. Yes, this is the road actually. This is what? This is road. They are standing opposite each other either side of the road. Okay. Which is 120 feet wide. What is the width of the road? This is AC is the width of the road. This is 120 meter wide. This is 120 feet, not meter. The width of the road is given that 120 meter, 120 feet. Okay. From a point between them on the road, the angle of elevations of top of the poles are 60 and 30. Angle of elevations are, let us see, suppose from this point E, angle of elevations of first pole, top of the first pole is 60 degree, and that of angle of elevation from the point E to top of second pole is 30 degree. This is the figure. Okay, poles are 30 respectively. Find the height of the poles. We have to find height of the poles, but given AB equals CD, since they are two poles of equal heights, let us denote it by H feet, which is equal to H feet. Okay, right now. And then also we have to find and the distances of the point from the poles. Okay, the distance of the point E from pole AB and from pole EC also we have to find. Let us denote it by is X feet, and this distance is Y feet. The distance from pole AB to point E is X feet. Distance of the point E from pole CD is Y feet. That is, we are letting AE equal to X feet and EC equal to Y feet. Just, and also the total distance X plus Y is AC, that is 120 feet. I am leaving this question for you people because the figure is there. Consider tan 60, tan 30 to get relation between H and X, to get relation between H and Y, and use this equation. You will get the value of H as well as X and Y. Okay, please try by yourself. Let us see two more problems in this exercise to conclude the part 3 of this session. So in exercise 12.2, let us see or discuss two more problems, 8 and 9, which are very important of the concepts, having important concepts in that. Okay, so students, listen carefully. The angle of elevation of the top of a tower. So let us see, this is the top of a tower. Consider AB as tower, A is foot of the tower, B is top of the tower. From two points at a distance of 4 meter and 9 meter. So at a distance of 4 meter, let us consider one point. This is point C. So distance from foot of the tower to point C is 4 meters. So we are observing from C also, and another point is from 9 meter from the foot of the tower. This is 4 units and this is 5 meters. This is point D. As distance from foot of the tower to point D is 5 plus 4, 9 meters. Yes. What is given? The angle of elevation of tower from 2 points at a distance of 4 meter and 9 meter. So foot of the perpendicular to point C is at a 4 meter distance, and foot of the tower from point D is 9 meter distance. Okay. Find the height of the tower. You have to find the height of the tower. Let us denote it by H meters, as these distances are given in terms of meters. Height of the tower. From the base of the tower, the angle of elevation of the top of tower from the base of the tower and in the same straight line with it are complementary. Here the angle of elevations from these 2 points are complementary in the same straight line. Join BC is a line of sight, and also BD, it is another line of sight. But these two angle of elevations are complementary. What is complementary? Sum of two angles is 90, then the angles are called complementary. Let us suppose denoted by theta, then automatically this angle is 90 minus theta. Add them, what we get? 90 minus theta plus theta. Sum of these two angles, theta minus theta gets cancelled, we get 90. Yes, sum of these two angles is 90, hence these two angles are complementary angles to each other. Theta complement is 90 minus theta, 90 minus theta complement is theta. So, given that angle of elevations are complementary in the same straight line from base of the tower. So, AD is a straight line from the base of the tower AB, and the angles of elevations are complementary. So, we have to take the angle of elevations from C is theta, from D is 90 minus theta. Thus, okay. So, we have to find the height of the tower, right? No problem. We have two triangles, right angle triangles in the figure. Thus, first one is ABC and second one is ABD. Therefore, given that let AB equal h meters and AC is 4 meters and DC is 5 meters and that of AD is 9 meters. They are given distances. Therefore, angle ACB comma angle ADB are complementary angles, angles to each other. Therefore, let angle ACB equal theta, that implies what will be the its complement angle? ADB equal 90 minus theta, as their sum is 90, therefore they are complementary. Now, in triangle ACB, tan theta, consider tan theta, opposite to theta, that is h by adjacent to theta is 4 meters, h by 4, it will be equation 1. And in another triangle, in triangle ADB, consider tan 90 minus theta, tan 90 minus theta. So, let us draw a triangle ADB. This is 90 minus theta, and distance from A to D is 9 meters is given. This is h meters, right? Tan 90 minus theta equal opposite h by adjacent 9, right? But we know that tan 90 minus theta, what is tan 90 minus theta? Thus, tan 90 minus theta is cot theta, 90 minus theta in the first quadrant, and 90 coefficient is 1, that is odd. So, tan may be changes into cot theta, cot theta equal h by 9, this is equation 2. Consider equation 1 into 2. Why? Because we know that tan theta into cot theta equal 1. Reciprocal of tan is cot. So, LHS, product of LHS, tan theta into cot theta. When we product two equations, we product LHS to LHS and RHS to RHS. What is the RHS here? h by 4 into this h by, RHS is h by 9. We know that tan theta into cot theta equal 1. They are reciprocals to each other. That equal h into h square by 9 4s are 36, 36 1s are 36 equal to h square. That is, finally we get h square equal 36, h equal, we get plus or minus 6, as minus 6 square equal 36, plus 6 is also, square is also 36, but h is height, so we neglect the negative sign. So that is h equal what? 6 meters. Therefore, height of the height of the tower. Height of the tower is equal to 6 meters. So important problems. Why? Because given angle of elevations are complementary angles. That's why this is important. Next, the flight question, jet flight question. It's very, very important. Okay, students, listen carefully. Okay, final question, ninth one. The angle of elevation of jet plane from a point A on the ground. First of all, we have to take a point A on the ground. Let us take a point A on the ground. This is the ground actually. The angle of elevation of jet plane. Suppose jet plane is traveling towards this direction from this point. This is point B. This is point B. So draw the line of sight from B to A. This is line of sight. The angle of elevation is 60 degree with the ground. The angle of elevation is 60 degree with the ground. After a flight of 15 seconds, after 15 seconds, let us say that the flight is traveled some distance from B to C. It moves from B to C. Now flight is here. Now flight is here. From this point to this point, it moving from this point to this point. Okay. After a flight of 15 seconds, the time taken to travel the point B to C for the flight is 15 seconds. The angle of elevation changes from 30 to 60. Now position of the jet plane is here. So draw the line of sight, but you are observing again from point A. The line of sight is AC. The angle of elevation changes from 60 to 30 degree. If the jet plane is flying at a constant height, it maintains constant height from the base, from the earth. So this is the constant height, height of the plane from the base is 1500 root 3 meters. So draw this one. This is also height of the plane from the earth. This is also equal to 1500 root 3 meters. Let us denote these 2 points by D and E. Okay. Find the speed of the jet plane. But we know that speed is equal to the formula distance by time. Distance by time. But time is given that 15 seconds. Let us write what is given in the question. BD is a height of the flight from the base or from the earth, and BD and CE both are equal, which is equal to 1500 root 3 meters. Okay, and time is given by, to travel from B to C, jet flight takes 15 seconds. Just it takes 15 seconds. So in order to find the speed, we have to find this distance BC. But BC is equal to what? DE. BC is equal to DE. That is angle of elevations BAE is 60 degree and another angle of elevation CAE is 30 degree. Right now we are having two right angle triangles having 60 degree elevation, angle of elevation, and another one is 30 degree angle of elevation. Okay, let us denote it by x meters and this by y meters. Okay, let AD equal to x meters, comma DE equal to what? Y meters. We have to find y meters which is equal to BC. So, since because jet flight takes 15 seconds to travel from B to C, and we have to find the how much distance it is traveled in 15 seconds, so that we can get speed equal distance by time formula. Right. I am considering a triangle D, this is point D, B, this is BD is 1500 root 3 meters, 60 degree, this is A. In triangle ADB, in triangle ADB, what is the angle of elevation here? 60 degree, and AD equal to what? X meters. Tan 60 equal to 1500 root 3 meters by X. Tan 60 is root 3 equal to 1500 root 3 by X. X into root 3. X into root 3 equal to 1500 root 3. Root 3 to 3 on equal sides gets cancelled. Equal terms gets cancelled on both sides. So, what we get? X equal to 1500. Yes, X value is, this is 1500 meters distance from A to D. But we need distance from D to E actually. Now consider in triangle, I am again drawing the triangle, that is A, E, C. This is constant height 1500 root 3, angle of elevation is 30 degree, and this is both are x plus y actually. This is x plus y, right. In triangle AEC, tan 30 equal to, consider tan 30 opposite to 30 degree, 1500 root 3 by adjacent to 30 degree, x plus y. Thus, tan 30 is 1 by root 3 equal to 1500 root 3 by x plus y. What is the x value? 1500. Substitute the value of x, 1500 plus y. By cross multiplication, 1500 plus y into 1, that is 1500 plus y equal 1500 into root 3 into root 3. Root 3 into root 3 gets 3. So, y equal to what? 3 1500 is 4500. Transform plus 1500 from LHS to RHS, it would become minus 1500. So, y equal to 4500 minus 1500, that is 3000 meters. Yes, this distance is 3000 meters. So that BC also 3000 meters. Now, but actually we have to find the speed of the jet airplane. That is, speed is given by speed equal to distance by time. To travel 3000 meter distance from B to C, jet airplane takes 15 seconds. Therefore, speed equal to distance is 3000 meters by time is 15 seconds. 15 ones are 15 twos are 30. Write down 15 zeros are 0, 15 zeros are 0. That is, speed is equal to 200 meter per second. Yes, this is how we can find speed of the jet aeroplane. Okay, students, this is part 3 of application trigonometry. Through this part 3, the chapter is over now. I am leaving some of the 12.2 exercise questions for you people. You can solve by your own. Okay, thank you very much. Thank you DUO Nalgonda. Thank you very much for giving this opportunity to me. Thank you very much.